examples starting now. So we're going to get a little bit more complicated, and there's a couple of extra tricks in these examples. The first one I'm looking at is this. Now, a lot of students find these easier when the base values are actually letters, pronumerals, rather than numbers, because they don't have to think about what the square roots of different numbers are as well. They can just deal with only the powers, only the indices. Okay, let's run through this one first. I now have two things inside the bracket, so I've got two different bases. When I've got two things inside the brackets and a power on the outside, everything in the brackets has to go to that power on the outside. So I'm going to have a base of a, and it was a to the power of -2. So this is a power to a power. -2 times 3 is -6. And don't forget, this b has a power of 1 there. Sometimes it's helpful to write the little powers of 1 so you don't forget them. b to the power of 1 to the power of 3. 1 times 3 is 3. Okay, then we get our fractional powers. Everything inside this bracket has to go to the power on the outside. There are shortcuts and tricks. I can ignore the 1 on the top because 1 to the power of anything is always 1. But just so that we don't overlook that, I'm going to write it down. I need 1 to the power of a half and b to the power of -3 to the power of a half. So both the numerator and the denominator have to go to the power of 1/2. And as I just mentioned, 1 to the power of anything is always just 1. And on my denominator, -3 times a half is -3 halves. All right, next step. How could I actually move on from here? Now, remember at the start of the lesson I said just because I do it one particular way, that doesn't necessarily mean it's the only way. If I was doing this myself, I would probably do it a little bit different to what I'm about to show you. What I'm about to show you is what I would say is a consistent method that you can use for a wider variety of problems. The next step I would take for you folks is I would set this up as two fractions being multiplied together. Why do I do that? Because multiplying fractions is easy. I simply multiply the numerator by the numerator, the denominator by the denominator. And I'm going to then rewrite this as a to the power of -6 times b to the power of 3 divided by b to the -3 halves. All right. Why do I do that? Because I've created this problem now that's just a division problem. And when I divide, what do I do with my powers? I subtract. So there's no other a's. So I'm just going to keep the a to the power of -6. And then b to the power of 3 minus 3 halves. The two negatives become a positive. And 3 wholes plus 3 halves is? And 4.5 as a fraction is 7 halves. Which one? 3 is the same as 6 halves. 6 halves plus 3 halves? 9 halves. Okay, last steps. Because these are just pronumerals, they're not actually numbers, I cannot do anything more with that 9 halves. I'm just going to leave it as 9 halves. All right? Negative powers though, as I mentioned, my preference is you write them as positive powers. So I'm going to drop the a to the numerator and make it a to the power of +6. We could do a little bit more with this problem. And I'm showing you this not because you need to. This I would mark as completely correct. But if this was a multiple choice question on an exam, it's very possible that they would write the answer like this. So they would turn that fractional power into a root problem. Then the numerator becomes b to the power of 9. So there's my numerator. The square root is from the denominator of 2. And then the a to the power of 6 is just the same as it was before. So that's using this rule down here. Completely fine. Also a possibility. All right. Okay, this question freaks people out and it looks really gross, but it's actually quite easy. What do you notice when you first look at this problem? They're the same numbers. The part here is the same as what's there. That might be a little bit easier to see if I actually write in the powers more clearly. So this one is to the power of 1. This one is to the power of 1/2. So this is just a really simple index multiplication problem where my base, instead of my base being a singular term, my base is this expression, this linear expression. So when I have multiplication, what do? I keep the base and I add the powers. What's 1 plus 1/2? 3/2. Done. If I wanted to be clever and write it with a square root, I could make this 2x minus 1 cubed with the square root over the whole lot. Again, perfectly fine. Could be the way that they write it in an exam multiple choice question to try and confuse you. Okay, Rani, are you ready to tell me what your question was that you wanted me to do? Can you read out, just let me wipe this bit of the board, can you read out what it was? I'll tell you when.
A to the power of 2n take 1.
Yes?
Times b to the power of 3.
Yes?
Times c to the power of 1 take n.
Yes?
And then like fraction line thing. A to the power of n take 3. Times b to the power of 2 take n. Times c to the power of 2 take 2n.
Okay. So we haven't got fractional powers, but we do have negative powers, and this is kind of similar to what we had here. Except it's not the base that's an expression, it's my powers are all expressions. The index rules still apply though. When I see multiplication, I think keep the base, add the powers. So look at our numerator. Do any of those terms have the same base? No. So I can't do any multiplication on the numerator. Do any of my terms on the denominator have the same base? No. So I can't do any of the multiplication though. So then I'll look ahead and I'll look at my division. We have two bases of A being divided. So when I divide, index laws, when you divide, what do you do with the powers? Subtract. So I'm going to write this in a little bit of a gross way, but I've got to show you the whole step. So my base number is A. I keep the base. And I've got A to the power of 2n minus 1 minus n minus 3. We keep the base, we subtract the powers. Okay, so this is the numerator. Sorry. Numerator power, denominator power. Keep the base, subtract the powers. So what's 2n minus 1n? n. What's negative 1 minus minus 3? Close? 2. Okay, that's the A part. Now, let's work with the B part. It was b to the power of 3 on the numerator minus 2 minus n. What's 3 minus 2? 1. What's 0 n's minus minus n? Positive n. And then work with the C part. Numerator is 1 minus n minus 2 minus 2n. What's 1 minus 2? Minus 1, I don't think anyone said it, but I've done it for you. Minus n minus minus 2n. It's positive n again. So, kind of like we had here, we've just got expressions for part of the problem, and we just have to work with those expressions, and it's simple algebra collecting like terms. Hint, I've put all of these brackets in because I've got to remember that the subtract is for both of those terms, not one of them. And if you don't write those brackets in, it's really easy to forget that and make a mistake. That's your final answer. I can't go any further, even though it looks gross. Would you like me to do this one? Okay, last example. Oops, x. Minus 1. Okay, so for this example, what do you notice? Millie. What do you notice? Alice. I don't know why I called you Millie then. I pointed straight at you and I said Millie. Alice. What do you notice? They're the same except for this one's a fraction, right? So they're the same, this one's a fraction, that part's identical. What else is different to everything else that we've done? Plus. All of our other things have been times and divide because we have index laws for multiplication and addition. We have index laws for multiplication and division. We don't have an indexed law for addition because they don't exist. So the way I'm going to do this addition is I actually just have to use my fraction rules for addition. How do I do the addition of fractions? How do you add fractions? I don't times them. You're going to need to give me more than that. You've got to get the same bottom number. What's the bottom number called? Denominator. So we've got to get the same denominator. How do I get the same denominator? I use multiplication, which is probably where you were going there, Francesca. So we have to get the same denominator. So I'm going to turn this 1 into a square root of x minus 1. How am I going to do that? I'm going to multiply it by the square root of x minus 1. But I can't just multiply the denominator by x minus 1. What do I also have to do? Multiply the numerator by x minus 1. Okay, when I do that, I'm not changing this first fraction, it stays exactly the same. The second fraction, the denominator becomes x minus 1, like we just spoke, because 1 times the square root of x minus 1 is the square root of x minus 1. The numerator, this is the same as x minus 1 to the power of a half times by x minus 1 to the power of a half. Now I can use my index laws. I keep the base, add the powers. Okay, keep the base, x minus 1, a half plus a half is equal to 1. Now that I have the same denominator, what do? I add them. So, do I need this brackets and power of 1 on the outside? No. So I don't need any of that. So I'm going to go 1 plus x minus 1. What's 1 plus x minus 1? X. And my denominator is the square root of x minus 1. We're simplifying. Simplifying doesn't mean it's going to be this nice, super neat little singular number, single value. That's as far as I can go here. That's your final answer. There was only one little bit of index laws. Everything else was fractions, and they're trying to trick you by being really mean. Okay, there's the last of my examples for today.